Hey, Mike V here from Reliable Automotive Equipment. Today we're going to be talking about aluminum dent repair. So before we get into some of the procedures of how it's done, let's talk about some of the processes of aluminum repair versus steel repair. Aluminum is a much lower temperature melting material than steel is, and it also has a much higher tensile strength when it's cold. It does not come out as easy as steel does as far as the process goes. It takes a little bit longer to finesse it out. Some of the steel techniques of being able to just bump something out, rough it out, and continue on with it doesn't always apply to aluminum. So on some of the processes that we're trying to do, the little setup right here is to try and put in as much equal stress across what you're doing instead of trying to concentrate in one little area, trying to have everything pull out evenly and nicely. Some of the differences in the aluminum, the major differences, there's two major groups of aluminum. One is called a 4000 series aluminum and one is called a 5000 series aluminum. So a 4000 series aluminum is ALSI, which is aluminum silicone as a generic name. It's really silicium, is a solid form of silicone. So the ALSI is the components, the silicone or the silicium that's into that ingredient is one of the main mineral contents in there. The 5000 series is an aluminum magnesium mineral setup, which is ALMG. So the differences between the magnesium and the silicone results in different characteristics of the aluminum product. It melts at different temperatures, it takes different welding programs. Any bits that we go to put on here, any of the pulling bits, any of the pulling studs, they do make them in the different grades of aluminum. They do make a 4000 series pins, they do make 5000 series pins, and they're also now on these, they are also making these in what they call pure aluminum, which is 98.5% pure aluminum. The reason for that is some of the outer panels on the cars do not have the high mineral content that they use in the structural process of the vehicle. So when you go to weld pulling bits on, pulling studs on, try and make sure that you have the correct grade of aluminum to weld onto that grade of aluminum. There is no universal welding wire for aluminum. Every manufacturer uses a slightly different grade. For example, this is a Mercedes hood. This is actually what's designated as ALSI 5. And that last number on there, that represents 5% silicone in the aluminum solution. Audi uses ALSI 12, so they use a little bit higher silicone content in their solution. The difference is that if you take Mercedes wire and weld on an Audi product, the weld will look good, but it will not have the structural strength as with welding with ALSI 12 wire. So please make note of this, that there is no universal aluminum wire. If you're welding a Mercedes product, you have to have specific wire for Mercedes. If you're doing Tesla, it has to be specific wire for Tesla. Generic setup is Tesla, Mercedes, Audi. They're all 4000 series ALSI product. You get into Cadillac, Jaguar, Land Rover, Ford F-150. They're 5000 series. They're aluminum magnesium. Does make a big difference when you go to weld the pins on. If you're trying to weld an ALSI pin onto a Ford product, they do not weld on well. So if you're having issues with that, check what type of material that you have that you're trying to weld on. The process of pulling the dents out, because it is a higher tensile strength when it's a room temperature material, heat is used to help relax the molecular structure of aluminum to help get the dent process going. The problem with heat on the panel is it will not change color like steel does. So as you are heating up the panel, you have no idea what temperature it is. And aluminum transfers heat very fast. So we're going to go into some of the heat products, the propane torch, the heat gun, the temperature strips, the infrared gun. You need to monitor heat very closely. General guideline is you really don't want to get past about 400 degrees on aluminum. Audi actually has their limit set around 320. The problem is when you start getting it up around 400, it's very easy for that heat to get out of control, get up to the point where when it gets too hot, it actually anneals the aluminum. It actually takes the tensile strength out of the aluminum. Once you overheat aluminum, you cannot retemper it again. So you have to have a little caution when you're doing it. Heat is your friend for straightening. Heat can also be your enemy if you don't use it correctly. So as we start going through the process here, we want to make sure that we have the right pins set into place. This particular setup right here is just showing a measuring bridge. In reality, I have this setting on the center point of the hood panel. In reality, we would probably go to a longer bridge. We want to make sure that where the feet are going on here, that it's a relatively solid part of the panel, because as you're putting pressure up on this, it's putting pressure down on the feet. So it takes a little bit of thought process, a little bit of common sense. When we set this thing up, we want to have this on it so we can put a little bit of tension on the panel, and now we can actually hold some tension on the panel without having to hold the puller itself. So that leaves your hands free for doing the heat, doing the temperature, and then doing stress relief around the panel. You'll find that the process of pulling the dents out of aluminum, don't try and pull it all out at one time. Do it in stages. It works much easier that way. A crease going across this way, if you put your studs on there, your pins, your bits, you have your pull bar, you start coming up, you'll literally see the whole panel pick up. The crease does not start coming out like it normally does on steel. So on the aluminum, you want to put some tension on it, put some heat around the high spots around the edges, and then you'll literally see the crease start to move back out again. So it's a finessing point of working the product and getting used to it. There is a big learning curve to doing aluminum. I recommend that you have some old panels in the shop, practice on them rather than trying to tack it right on a car. The more that you work on it, the more you get used to the characteristics of aluminum itself. It doesn't react like steel, it doesn't straighten like steel, it doesn't weld like steel. So you can't have the steel mentality as you're trying to go into the aluminum process. You want to make sure too that any of the products that you're using on aluminum are dedicated for it. You have a dedicated hammer. If you have a dolly that you're using, make sure it's dedicated for aluminum, because cross-contamination, if you have any little particles in the hammer from hammering on steel and then going on to aluminum, you will actually bury those products into the aluminum. And on dent repair, your biggest problem is paint failure down the road. Because if you have a little steel product in there and you get everything covered and painted, it looks good, it's down the road, about 9 to 12 months down the road, it will be coming back where it's starting to blister and bubble up. And when you scrape that up, you'll see the little white powder in there, and it's oxidation of the aluminum and the galvanic reaction with steel. So just be careful on that. And then we're going to go through how to set up on the studs. So this represents the bridge action. We can actually take the studs that we have over there too. We're going to set up some rings on that to also show up how to set that one up. Okay, so we showed a little bit of the bridge over on the pulling bits over there. So in an area where you have studs, you have a couple different options on doing these. We can do these an individual at a time with some of the pulling attachments. There are several different ones that we have here, so we're going to show a couple. We can put a little mini bridge right over this piece here, slide this into the piece, little screw adjustment on it. And again, watch where you put the feet of it. This is kind of more of a demonstration right now, but this is able to put some tension on that pin coming up. And remember, the objective is not to pull the pin off. You want to try and make sure that your pins are welded on securely. As you learn and practice this, to have the settings correct on the machine so that the pins just don't fall off when you start pulling them. And you don't want to weld them on too much, because if then you go pull too much tension, you will actually pull a hole in the panel. So this is another nice little way of doing something simple, of being able to still work the area and not have to hold up on the pull process. If you do have an area that you do want to pull up on do just a single pull on one piece, we do have the one little attachment that will slip right on top of one of the studs. That'll just go right in and lock into place, and then you can pull each one individually. This here will just pull up, pull back off again. We do have rings that will go on top of here. So if you have the stud process, you can make this end up looking like that by putting these on and doing the same process on that by putting that across, putting a pin through, And now you can pull up multiple spots at one time. So you also have the process where you can use this puller too, and you can do multiple pulls by turning the pieces where you want them, put the hooks in, put your base where you want it, and pull up on it. So you have several different options on that. You also have, I don't know if I'll be able to get the ring around that, on these that we can put on, hook into, and then you can also use the lever, pull each one individually, and also have a ring base around here to push down on the high spots as you're pulling it. Okay, so as we're going through the dent removal process, we talked about using heat. So here are a couple of different options. There's some really good quality heat guns out on the market that will get up to a nice high temperature range. Our goal on this is we don't really want to get it past 400 degrees. Probably somewhere around 350 is a little bit safer working area. We're going to do some demos on this, take some readings on it, and actually see it really doesn't take that much heat to make something move. So a couple of the different heat guns, they do come with some different attachments where you can actually make it into a concentrated area for heating up better. The downside of this versus a propane or a MAP gas torch, these take longer to heat up the panel. That is much quicker. The problem with that being much quicker is you can easily get out of control with the heat a lot easier with the torch than you can with the heat gun. So we have a little infrared temperature indicator here, and we also have some heat strips that these will change color as the heat range goes up. So the nice part about these is that we can just peel these off. We can put these right on the panel. So if we're going to be working in this area, I can watch those also as I'm shooting it with the laser gun if I need to. And one thing about the laser gun, when you shoot a laser gun on aluminum versus paint, you are going to have a little bit of a difference of temperature. This is not going to actually show the true temperature when it's on clean aluminum. It'll actually show a little bit less because the way that the laser light works is a reflective process. This actually reflects it a little bit more than the paint actually does. So if you're working in this area with the laser light, we'll just keep bouncing the light down onto the paint area and see how much the heat is transferring out. So this torch kit, this is a really nice kit. You can use this on regular propane gas. MAP gas is actually a hotter gas than propane. So again, the advantage is it heats up very quickly. The disadvantage is it heats up very quickly and it can get away from you. So just by, again, testing on old panels, this is where you can really, if you make a mistake on it, you're not going to hurt anything. But it really gets you used to how quick the aluminum heats up and how little bit heat it really does take to start moving the product around. The nice thing about this particular torch, this is part of the Mercedes program, the nice thing about this torch is this has a nice, quick, easy disconnect on putting a different tip on here for a different flame. And just that quick, they'll change out, and you get a longer flame, a shorter flame. You can get one as a very wide blowtorch. This is great for if you're taking off decals or something. You have a much wider flame. It's not as concentrated, but it creates a nice amount of heat. All right, so what we're going to do is a little bit of MAP gas. We're going to be looking at this little dent right here. If you're in the shop, it's great if you can catch an overhead light. If you move around and see where the light comes across it, it just explodes out with the distortion of the aluminum. So we're just going to turn on our gas here. I got my temperature strip on there. I can keep an eye on that. If I start going up into the temperature range, these strips will turn almost a black color. So as they change color, that means that you're already up in that range. And when the first one starts, it does not take long for all the other ones to go after that because it's a very rapid acceleration. So torch, I got my little infrared gauge here. So all I'm going to do here is a little bit of heat. And you can see that coming out, 200 degrees right there. So it's not that much heat. You can see it bump up. Now you're going to see it as it cools down. It'll shrink back down a little bit. Not all the dent is out, but a good portion of it is. Right in the center part right there, it's smaller than what it was before. And you can see it slowly just shrinking back down to level out. We'll give that a chance to cool down. The nice part about that is you can keep hitting this with the torch. Let it cool off, hit it again. It'll do the same thing again until it's almost totally out. And by working with this a little bit, the finessing process, we're not trying to force it out with a lot of heat. If we understand how aluminum reacts to tension and heat, then we know how to work the process. And by working the process and practicing on some damaged panels that you don't really care about, you can push the limits on it and see when you've gone too far, and then know not to do it when you're actually doing it on the car. So that's actually cooled down relatively decently. So I'm just going to hit that again right now. Right in the center, work your way out, come back in again, hit the center. 220 on that one. And as you can see, the paint itself hasn't even blistered up. So it's not a tremendous amount of heat, but that amount of heat will actually start working that dent out by itself without even hitting it with a hammer. So, and again, you can see everything swelled up again, it's shrinking back down, and now the center point of it is much smaller than when we first started. So your big thing on heat, controlling it. You notice the torch was not on it that much, but it worked very quickly. A heat gun will work better when you're doing a crease along the panel that you want to heat up the area more evenly going across. This is great for a quick shot right into a small little dent like that. Okay, what we're going to do here is just show how the temperature strip actually works. As the heat gets hotter, these strips will start turning black on down the line. This is registered in Celsius, so I'm going to take the laser gun and point it as it's heating up, and that'll be shown in Fahrenheit so you can get an idea of the temperature. See, it's starting to change right now. All right, so we did a little demo on the heat strip so you could see how that the little zones changed as the heat went down the panel. Interesting aspect here, when they had the little infrared gun on it for getting the temperature, it does not give you the exact temperature that it is because it is a reflective surface. One of the things you can do is put a piece of masking tape there, or if you're on an area such as the hood area where you have paint area, if you can run the light over to the paint, back over to the aluminum again, you can kind of get a difference of what that amount is. It's generally running about 10 to 15% less of what the regular paint on top or something where it's not a reflective surface. One word of caution here, we talked about using the torch, open flame. Don't use it around when aluminum dust is present. Use a little bit of common sense, please. The heat guns do work great. They will get them up to temperature. The little demo that we did with the flame on the actual hood assembly, there was really no bare aluminum hanging around. Use a little common sense on that. So, a couple of things here I do want to talk about. We have shown these bits that have been welded on, and this is actually done with the carbon unit that does aluminum stud welding and aluminum bit welding. We do have a video on that on our website. It's called the carbon unit. You can watch that on how these actually go on. The difference between these and the studs that we put on the hood assembly, this actually welds to the top part of the panel. The studs actually weld into the panel, because when studs actually get welded onto the vehicle, They're actually being used as something to support, whether it be a ground wire, whether it be a wiring harness, whether it be a wheelhouse assembly. So when we weld a stud on the panel to do dent repair, that is why you have to be very careful, because if we take one of these and instead of cutting them off and this thing ends up pulling off, you've actually taken out a chunk of aluminum of the panel. On this particular one, we'll get a close-up view of this. You can actually see a droplet of aluminum on the upper panel, and when these tabs come off, you're only left with a little bit of aluminum sitting on top of the panel. It does not eat into the panel. These are much better to use with less chance of tear out on the panel. Okay, one of the last items we want to talk about doing the aluminum repair is there's a lot of the OEs now requiring that after you've done a repair to check for any stress cracks in the aluminum panel. So what I'm going to do today is a little demonstration on the crack detection kit, which is normally used for welds, but now they're actually upping it up where they want to check the repair panel once you've done pull everything out to make sure that there are no stress cracks. So the procedure is that we clean the panel with a wire brush, make sure that all contaminants are out of the way. We're going to take a special cleaner for the aluminum. The first time that we use this, we can spray it right on the panel. Then we just take a rag, we clean it. What we want to do is get rid of any contaminants, any dirt that's in the area. Then you actually want to let this set aside for about 10 minutes or so. So if there's any solvent inside of the cracks or any pores, it gives it a chance to evaporate. So once the panel has dried, what we want to do now to it is we want to spray a dye into it, which is called a penetrant. And it's just a red dye. It looks a little bit like candy apple red. And all we want to do, simple as that. So that is now going to sit on the panel for about 15 to 20 minutes. And what's going to happen, the red dye is going to soak into any little cracks, any crevices, any pinholes, porous areas. Once that sets up, and it doesn't really dry, it still stays wet, but after about 15 minutes, we're going to do the same thing that we did before cleaning the panel, except of spraying on the panel. Now we're actually going to take our cleaner, spray it onto the rag, and then we're going to clean off all the red residue that's on there until everything gets cleaned off. You will see little trace elements here and there, and that's okay, because all we want to do is get the bulk of the material off. Anything that's gone down into a pore is going to stay there, so we don't want to spray the cleaner directly on the panel. So once we have this cleaned, then what we're going to do is spray on what's called a developer. And this goes on translucent, and it turns to a white powdery substance when it's done. So shake this up, and all we're going to do, so right now it's a little bit translucent. As that dries, what that's going to do, it's going to pull out any of the dye that was left in the components. So this panel was all cleaned off before. We sprayed the dye on, we let it set up. It becomes a little bit of a powder right now. And it's showing us anywhere where there are red marks, you have a problem in the panel. So when you're checking your panel for destructive, if everything turns off white, you don't see any little hairline red lines in the panel, you're good to go. So this is the way that it's done for welds. This is also the exact same way that it's done on a panel that you've done repair on to make sure that there are no stress cracks. Okay guys, that wraps it up for the aluminum repair part. Name in front of you, number in front of you, go on our website. You have any questions, any concerns, give us a call, check us out. Thanks guys, have a great day.